Welcome everyone. Today we are going to solve another interesting DSA problem which is titled as Valid Sudoku. So Sudoku is one of the very popular puzzles. So at least everyone has tried solving Sudoku at some point. And let's try to understand the problem statement. So you will be given a Sudoku puzzle and it would be given in the form of arrays. Like as you can see, this is a two-dimensional array. So if you see the pictorial representation of the Sudoku in the left side and the array list representation on the right side. As you can see, the rows is nothing but another array inside a main list. So like that, each and every rows has been given as an input and the array name is given as board, and this is nothing but representation of this particular array. Whenever there is an empty slot, you can see there also there is a dot mentioned here and there. And what the problem statement tells us that if we are given with a two-dimensional array that is nothing but the representation of a Sudoku, we have to check whether this particular input corresponds to a valid Sudoku or not. So there are certain rules associated to check whether a Sudoku is valid or not, and many of them have already known, but we can explain it one more time. The rule number one is nothing but each row must contain a digit between 1 to 9 without repetition. That means if you take in a row, we should ensure that there is no repetition of numbers and must contain a number from 1 to 9. If 3 is already present here, a 3 should not come here. If it's present something like that, that means this particular Sudoku is invalid. The same applies for the columns as well. So each column must have a number 1 to 9 without repetition. This applies for the boxes as well. As you can see, this is a box and this is a box. Like that, there is 9 boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 boxes. All the 9 boxes. Inside each box, it must have a number from 1 to 9 without repetition. So this applies for the boxes as well. Each box must have a number 1 to 9 without repetition. And how can we check the given input, which is nothing but the representation of the Sudoku, is valid or not? What we can do? We can use the help of hash sets, and we can try to solve whether this Sudoku is valid or not. So we can straight away jump to the code, and each step I can try to explain how it's connected to solving this particular problem. Let's straight away go to the coding part. I hope you have understood the problem statement. So this is the coding part. As usual, we are going to write the class definition and the method definition inside it. So define is valid Sudoku. That's the name we have given. Sudoku. What are the arguments? The representation of the Sudoku board, which name is given as board. And what we are going to do, we are going to use the hash set. So basically we need a hash set, 9 hash set to represent 9 rows and 9 hash set to represent 9 columns and 9 hash set to represent 9 boxes. And we can simply write those representation as like this: rows equals an array which is nothing but hash set for dash in range of 9. So what does this do? Let me tell you. This does nothing but this create a row which is a 2-dimensional array that would be having set like that. It will have 9 hash sets inside it, and each hash set will make sure an element from 9 to 1 exists only once. That we would be utilizing this particular feature of this thing. Same applies for the columns as well. So let's write the columns and box session also. Columns is equal to set for dash in range of 9, and boxes also. Set for dash in range of 9. Now we can iterate and gather whatever be the information given in the input. Now let's use that. We have to go by row and column wise because it's a 2-dimensional array. This board is nothing but a 2-dimensional array. So we can write for R in range of. So one thing we could have done it better. Since the board is a 2-dimensional array, I should have wrote it with all the information, because this will allow us to understand the problem also. This is nothing but a list. Inside there is another list of string, and I should have also written what is the return statement. That's nothing but a boolean. So this gives much more idea. This is how we practice. Now let's go back to solving our problem. For R in range of 9 and for C in range of 9, let's gather the value from the input. Value is nothing but board with appropriate indices R, C, and we have to check whether this already in the hash set or not. Let's do it right now. If value equal to the dot, which is a character, we can continue. We don't have to bother about anything. This is not going to decide anything regarding the validity of the Sudoku puzzle or not. Now we need to check if value in row R, whether it's present there or not. Before that, we should have added the value. Let's keep an empty space here. That means we have to fill something here. So we should have filled, if this is not present in there, we should have filled like rows of R dot add value. We should have add the value, something like that. And even if adding, if we are seeing it again, that means there is a repetition. So in that case, we could have returned false. Same logic will apply for columns also. If column in, if val in columns of C, if that's present in that indices, then we should have returned false. If it's not seen, we should have updated columns of C dot add value. Like that, we are going to see whether the repetition is happened in rows or columns as well. But in the boxes, let's go back to Sudoku puzzle. There is box number 1 here, 2 here, 3 here, 4, 5, 6, 7, 8, 9. So we can also represent 0, 1, 2, 3, 4, 5, 6, 7, 8. So these are the box indices. So in order to appropriately access the box indices using the R and C information from 0 to 8, there is a transformation. So the box indices is nothing but whatever the R is given, do the floor division with 3, multiply it by 3 plus C floor division by 3. So what does this R by 3 does? So ranging from 0, 1, 2, the R by 3 would be giving 0. That means it's representing this topmost boxes. Same applies for C also. C by 3 in this case would be taking this column also. So whatever the intersectioning, this would be the answer. But if something like 3, 4, 5 comes, the rows would be going to represent the middle one. And this column will also represent the middle one. So you accessing the R and C to locate what is the exact box indices is what we need to do. So with that, we have to check what is the box indices with the given R and C. We can do this thing. Box index is nothing but R by 3 multiplied by 3 plus C by 3. And same, we have to check whether the value is present in the boxes or not. Value is present in the boxes. Here the indices are not R and C, it's box indices which we have calculated. Indexes. If it's present, we have to return false. If it's not present, we would have added that thing. Boxes and the box index dot add value. Once this is done, we have checked its eligibility whether it's going false at any point or not. And that's it. At the end, we just need to return false. If it surpasses all the tests, return true. And the question is, what is the time complexity? As you can see, there is a back-to-back loop, but there is a catch. We are looping it only 9 times. 9 is nothing but n in our calculation. If it was n, the time complexity would have order of n square. Since n is 9, is nothing but 9 into 9, the time complexity. So the time complexity in this problem is nothing but order of 81. That's a constant. It's a constant. And space complexity is also like order of 9 into 3, because here we are using 9 sets, so 9 into 3, so that would be 27. So that's also a constant. So you can also, if required, you can write order of 1 also. Since it's limited, we can just write things like this. So this is a intuitively very good problem, and it gives a lot of like ideas about representations and how we are checking the validity of a Sudoku puzzle or not. And I hope you understood, and thank you for listening.